So just starting out, we're talking about expressions and equations. And this is 3.1.2. Again, today and tomorrow are going to be very, very related. We're basically learning the process in the forward direction, and then tomorrow we're going to learn it in the reverse direction. So very related. Somebody first tell me, expression versus equation. What's the difference between those two math situations here? Yeah, Riley.
An expression has no equal sign and an equation has an equal sign.
Good. So expressions we can reduce and simplify like we did so here. If we have an equation, then we actually solve for the missing variable. We can do a lot more with equations. Okay, that's the only difference, just vocab. And then let's do a little bit more vocab when I'm talking about perimeters. Perimeter, I'm speaking about what? If you're guarding the perimeter, what are you doing? Yeah.
The outside.
The outside. You're guarding the outside? The outside of the shape? Yeah. What were you going to say, too? You said something.
The distance around.
The distance around. Distance around. So I like to just make a quick little note, just the distance around. And I know a lot of you know it, just want to break it down even more. The area, if you're putting a tile in your room, right, it's how many tiles will fit in there. So you have a side and you have a side. You'd multiply them to find what was in the inside. Actually, because it could be any shape, let's go with length and width. Length and width. What kind of units do I end up with area? I end up with what kind of units? Yeah, Jackson. Squared units, right? Units. Squared. Perimeter is just a distance, right? It's just a distance. So we're just talking about units. When we refer to perimeter, we're just talking about the units. That's all. So this is just the warm-up, the review, getting us going. So I'm going to push through this pretty quick. If we have a square that is 9 by 9, the perimeter, since they're all the same, is just going to be 4 times that side. 4 times the side, which gives us 36 centimeters. 32, it was 8. I didn't count. So it's 9 times 4. The area of that is going to be whatever that side is squared. In this case, it's 9. So 9 squared. 81. 81 what? Centimeters squared. And, you know, I didn't say that this was centimeters. I guess I should probably label that such. Let's do it in centimeters for everything. So just add that to your notes real quick. Last period I just said units and units squared, but we'll just make it centimeters. It doesn't matter what the units are, right? Okay, good. Now, is it going to make it much trickier if we have a number that is distinguishing the length of the side versus an expression that's showing what the length and the side are? It doesn't change it at all. It doesn't change it at all. So in this case, we're still using the formula 4 times the side, and we're just going to put in what the side is. Go ahead and on your own, just distribute that out. Get that expression. Put the right units on that. Make sure the units are right. And you can check with your neighbor if you need to on that. So we're just distributing this out. All right, 4 times x, 4x. 1 times 4, 4 centimeters. Perimeter just has centimeters. Now, the reason I put the parentheses around that expression is you don't want to get confused. It's actually the reader or the person interpreting what you're writing down here is going to need those parentheses to show that the entire expression has a unit value in centimeters. So sometimes we're going to have a long expression, just put parentheses around everything, so it's everything in that parentheses, centimeters squared, units squared, whatever you need there. All right, go ahead and set up this next one. What am I going to put in here for my side length? And then go ahead and work that out. Well, maybe we can give others a hint. What's our length for the side? X plus 1. Okay. So now go ahead and work that out. Remember, this is your base. This is your exponent. So we're going to take that base and multiply it just by itself. Yeah, maybe you can do that in your head even. I'll give you a moment for that. So this really is x plus 1 times the x plus 1. Everybody agree? Right. X squared, 1x, outer is 1x, so we get 2x plus 1. Now, what is wrong with this? Centimeters what? Squared. Okay, whole expression, centimeters squared. Good. Right. Okay, next. I want you to think of it this way. You had this example here. We just had to find, the area and perimeter for each of those shapes. What we're going to deal with next is, what if I have one square here that is 8 centimeters by 8 centimeters? What's the area going to be for that? 64 centimeters squared, right? Okay. What we're going to do, and what the main idea for today is, if I'm given some hints about how this first square changes. So instead of it being 8 centimeters, I say, I need you to make me a new square that halves the sides of this square. Then what are my new sides going to be instead of 8? 4, right? 4 centimeters, 4 centimeters. That's pretty easy too. We know we can read the difference and we can make the change, make our new diagram, our image. And then what is the area for this going to be? Centimeter square. Okay. So based on the change in the length of the side that we're going to be told to make that change, we then are going to be comparing. Almost. We're going to compare the two areas that result. And then how would I describe this? We have a 64 and we have a 16. So what would you say as far as we cut the length of the sides in half? I went from 8 to 4, right? What happens then with the areas? But if I go from 64 to 16, not square rooted. Square root of 64 is 8. Very close. It is a reduction by what factor? What is it reduced by? 1/4. So we'd say that when we change the length of the side of a square by half, then the area is decreased by a factor of 4, or it's 1/4 of the area. You see those two connections we're kind of making? When we change the length, what happens to the change in the area? That's the main part. We're dealing with squares for the lesson, but one of the problems in the homework has you deal with a cube, which when you get to that, number 10, I'll try to explain it with a visual if you need that. But the shapes, it really doesn't matter. We're just changing the sides in a certain way, looking to see what the areas change. All right. Great. Let's press on then. All right, so that's basically what I described here. We're going to draw a diagram of the original, find the area and perimeter of the original, then complete the steps 1 and 2 for our new shape with that decreased side or whatever they say. So, and then at the end we compare the shapes, find that difference between them. So let's draw the shape for this one. A square with length x centimeters. How about I just put x centimeters? X centimeters. Everybody agree with that? Okay, we're going to just find the area expression for this. Well, no, it's an equation. Area equals what? X squared in its area. So what kind of units do we have? What kind of units? Good, centimeters squared. Okay, everybody see that? So we found this is the original square we have to deal with. Now we need to deal with the modified. Now we have the length of each side increases by 2 centimeters. So let's go back, let's make our diagram. What should I put for my sides in that case? Instead of x? It increases by 2, so we are just going to go x plus 2, all parentheses, centimeters. X plus 2, parentheses, centimeters. Okay. Work out that area equation for me right here. Area then is equal to what? You know?
X squared.
Let's give everyone a moment.
Okay.
I know some people know before I finish my sentence what the question. Okay. So you may have to use FOIL. You may start to see, whenever you square an expression, there's a pattern that you'll see. I'm going to need you to show me what that pattern is in a moment. But we're going to take x plus 2. We're going to square it. The units are centimeters squared. So here, you could think of x plus 2 as, okay, it's just x plus 2 times x plus 2. And what's my new trinomial with that? X squared plus 4x plus 4. Put parentheses around everything, showing that the centimeters squared units apply to the entire expression. Within an equation, I can refer to part of the equation as an expression. So even though this whole thing is an equation because it has equal sign, that's what area equals, this part of it I can refer to as an expression. So you can have an expression within that equation, not the other way around. Okay, we've done these steps. We have the new shape. Now we have to find the difference comparing the shapes. And in fact, we're going to compare. I'm gonna even define this further. We're going to compare the areas. Okay. Let's look at this now. We have the first shape, our original is x squared, centimeters squared. Our second modified shape is x squared plus 4x plus 4 centimeters squared. What is the difference? Literally, what is the difference between this expression and that? Woody?
It increased by 4x plus 4.
Good. How do you know it increased?
Because
you're right.
You can cancel out x squared and other x squared and it's positive.
Right. That part is true, but I don't know if that reveals why it increased. There's a real basic, a real basic hint. Yeah.
Because you increased each side by 2 centimeters.
Right. Right. If you have a square and you increase the sides, you're going to increase the area within it as well. Okay. So I'd say that the change in the area, it increased by 4x plus 4 centimeters squared. See? We find the original. We see how they want to change the sides, and then we can look and see how that changed. What's the difference in the area? How did the area change? Okay, so this is today's lesson, just to kind of give the basic ideas. I'm trying to give you basic notes so that when you get to the homework classwork, there's a little bit more you have to kind of figure out on your own. Okay, so I don't want to give you all the entire route through this. I'm going to bring this over here. Stuck on. Thank you. Everyone just turned off there. All right, we'll do these together. We have 3 different examples here, or 2 modifications of one original problem. Now, this is where we're going for tomorrow, and this is a real easy, straightforward example. If I know that my equation for area of my original square is z squared centimeters squared, what is the length of my original square? Z. Everybody see that direction? You see how that's like a real easy example? Okay. If, just hypothetically, I had z squared plus 2z plus 1 as my area, just as a hypothetical, what would each side be in that state? Let's give everyone a second. So we're going the other direction. We know the area. We want to go to the length of the side. And maybe there's something over here that's going to be an expression as my length of one of my sides. So, Udia, what do you think of this?
Z squared plus 1.
Z squared plus 1. We'd have to factor this trinomial into 2 sides that are really my length and my width. Z plus 1, Z plus 1. You see how you have to go the other direction. You have to work your way backwards then. Okay, that's for tomorrow. Today I use this example to kind of give you an idea that when I have Z squared as my area equation, the side length must be Z centimeters. If that didn't click right away for you tomorrow, it definitely will. We'll practice this tomorrow. But you see how it's just going the other direction. It's not so bad. Don't worry if that didn't click. That was foreshadowing. It's a foreshadowing aspect. That's not a math word. What? Question? No? Okay, great. All right, we have a square. I was just saying we need to fill in that box. We know that the square with length is z centimeters. So let's make our diagram. It's a square, z centimeters, z centimeters. Right. All right, first modification. The original side decreases by 3. So let's see, here's my square. What should I put if the side, which was z centimeters, decreases by 3? Z minus 3 centimeters. Z minus 3 centimeters. Okay. Go ahead and find the area for that. Everybody can find the area pretty quick, I think, because it's just whatever the side is squared. And then go ahead and work it out. You can use FOIL or just look at that pattern. You probably got the pattern already. You got the homework done in your head already? No. Weird. All right. No. Well, what goes in here so we can help everybody out? You're going to the other step, and your first term would be z squared. I see where you're at. All right, let's give everyone a sec for this. So we know that the side is z minus 3. We're just squaring it because the area of the square is the side times the side. So let's see what we get. It's z minus 3 times z minus 3. So first, z squared. Outer minus 3z, inner minus 3z, so let's go minus 6z. Negative 3 times negative 3, 9. Parenthesize, centimeter squared. Okay. This is just another example. Instead of just adding or subtracting some degree, some length to the sides. Here we're going to take the original. Original sides are halved. So talking about half. So if it's halved, what should my diagram look like? What do you think? The original side is z. So if I halve that, what should I put in for my side length now? Okay. And maybe a direct way to write it in would be z over 2 centimeters. Z over 2 centimeters. We just divide z by 2. We have it. Okay. This one will be quick. We don't have to do FOIL. We're basically just taking z over 2. We square it. That's z over 2 times z over 2. And when you have two fractions, when it's multiplied, you do not have to find a common denominator. You can just multiply straight across numerators and denominators. So then we end up with area is z times z is squared. 2 times 2, 4 units, centimeters squared. You see the process we have to go through? Now, there's going to be some, again, in the homework that you have to deduce some other parts to this, but you have all the parts to figure them out. Okay, there's going to be just a little bit of deduction you have to do. Now, how it changed is you're going to write how it changed compared to the original. So we have this new equation here, z squared minus 6z plus 9 centimeters squared. So what is the change? Up here we had z squared centimeters squared. Going from this expression to this one, what's different? Let's give someone else just 1 second. Yeah, Zarafsha, what's the difference here?
You decrease by 6z plus 9.
Good. So we had a change in the area, delta, change in the area. Right. And you said a decrease of negative 6z plus 9 centimeters squared. How did you know it was a decrease? It's totally correct. And it's not necessarily because of that negative. We can even go back a little bit further to get a clue. What do you think?
Because you decreased by 3.
Oh, there it is. Because the side decreases by 3, right? If you have a large square and you decrease the sides, you get less area in the middle. More area, it's going to decrease. The reason I said don't look here at this negative is because right now we're dealing with squares, but if we have rectangles, you may have some different values that might make it negative, but it's not necessarily a decrease. Okay? So look at all your clues. Right there. All right. How about this one? Compared to the original, what is the change to get down to this?
It changes by a factor of 4.
4. Okay. The area changes. It changes in which way? Which direction? Does it get bigger or smaller? Smaller. Okay. So it decreases by factor 4. There's a bunch of ways to say this. I like that one. What's another way just to describe this? There's a bunch of ways. It's just how you verbalize it. You know, you could say it's 1/4 of the original area. You could say that. You can go the other direction and say the original is 4 times as large of an area. So you see the last part is going to be kind of how you verbalize it. Make sure you're as clear as you can so your grader, you know, it makes sense when we get back to grading this. All right. Thumbs up, sideways, down for this. It's kind of hard for me to tell. It's the week after finals. Everyone's a little fried. Tell. All right. No, thumbs up. Good. All right. So again, tomorrow we're going to go the other direction, given the final equation, find the sides, and figure out what the change was based on those 2 areas. But to start, go ahead and you have to do page 23, 1 through 10. I want you to do numbers 1 and 2 last. Numbers 1 and 2 are kind of the ones that we didn't get all the information for, but I know you can figure out from what we did. Okay, so we have plenty of time. We got a good 24 minutes. And we'll just remind the viewers to subscribe. You're number 79. You get a Kit Kat. Halfway through the year, and I don't even have 79. Oh, what am I doing wrong? Should I double it? All right. 79, you get a king-size Kit Kat. I have to go buy that special. What's better? What do we need to entice subscription? What?
Oh my.
I don't know. I'm too old to know what that is.